if a car passes you, in the left lane, what does that mean? Car passes you. Who's faster, you or the other car? All right, passes you. In the left lane, so I guess it's me, and the car passes me this way. In the left lane, going 90 kilometers per hour north. That's fine, whatever direction, sure. While you are driving 80 kilometers per hour north, how fast is the car moving relative to your car? Okay, question for you. What if someone catches up to you and then you go together? Are you both still moving? But relative to you, is he still moving? Because he is still exactly what? Next to you, besides you. So to you, what's their speed? If something is not moving with respect to you, their speed is what? Zero. Because okay, how about if someone catches up to you and then what? Starts moving, no, starts moving backward. That means what? They are moving what? Backwards relative to you. How about if they pass you, they're moving what? Do you see what I mean? So even though sometimes technically you could say he's not moving with respect to me, you both are what? You both are still in what? In motion. So my question is here, where are the objects here? You have to identify three. Who's the first object or observer? Come on. You. So let's say car one is you. Who is the other object? Okay, that's two objects so far, two observers. I need a third. What do you think the third one? By the way, this is gonna be a standard thing in relative motion problem. If a third object is not mentioned, what do we take the third observer to be? Or we already mentioned car one and car two. I need a third one. But where are they? By the way, both cars are observers, right? So we have to. I need a third one. Say again. What? Good. Where is the watcher? Exactly. Whenever something is not mentioned, so the third one, we assume the third one is the what? Is the ground. Is the what? Is the ground. So those two speeds, those two velocities are according to who? To the what? To the ground. So everyone, am I moving? No. So I am the what? I am the absolute watcher. I see how many cars in front of me? Two. You and someone else. I say that you are moving at what speed? Sorry, you are moving at what speed? 80. The other one is moving at what speed? 90. So okay, let's actually what? So let's start the. Oops. Sorry. Wow. Let's start the problem. So do you have one slide or two slides? Yep, we have enough space under it to write the solution. Okay. So how many speed velocities do we need to identify? No, three. Okay. So first, everyone, let's do this. So we need to identify the objects. What's the first object? Car one, car two, and then the ground. What should be a good subscript for the ground? G. Yep, always capital G. All right. So everyone, so let's write this here. Okay. So let's call it car A, car B, and ground. So A equals car A. Go ahead. B equals car B. And G equals what? Ground. Okay. Which one are you, car A or car B? Doesn't matter. Let's say you're car A. Let's say you're car A. Okay. So what's the speed of you according to the ground? Sorry, what's the velocity of you according to the ground? 80 kilometers per hour. Velocity. I need a what? I need a direction. North. Okay. So go ahead, everyone. V of car. Okay. How are you gonna write it down? I want what's the velocity of car A according to the ground. So what do I say? Do I say AG or GA? AG, because it means what? A according to G. What's up? Sure. So VAG is equal to how much? 80 kilometers per hour. In which direction? Okay. How about the velocity of car B also according to the ground? Hmm. What about the speed or the velocity of the other car? Yeah. 90. 90 kilometers per hour. Also where? Southwest. Now, what is the question asking? How fast is what? The car. Which car? B. Moving relative to? Which is car what? So what's the question asking for? VBA or VAB? How many people say they're asking for VAB? What does VAB mean? Velocity of car A according to car B. But that's not what we want. We want what? Car B according to car A. So we want VBA. Perfect. VBA equals what? Question mark. Okay. I need someone to write the equation now for VBA. Remember, two things are mentioned, one thing is missing. How do you write the equation? Okay, let me write it here. So VBA. Okay, who would like to finish this? Come on. Okay, Yasmin, go. And you have to explain to us why you choose whatever you got put down here. Oh, me? You're good? So it's B here and G in the middle. G. Perfect. Okay, everyone, look at the inputs that we have. Do I have VBG? I do. Do I have VGA? I have V what? Do you remember what me and Omar did yesterday when I told him to move and I moved? Or sorry, he moved, I didn't move, but I appeared to be moving to him. No, but my question is, I have VBG. It's right there. Here's VBG. I do not have VGA. I have VAG. Thank you. Remember, when he moved, by the way, do we have the same grid? Do all objects have the same grid? You have to. So Omar moved this way. So to me, he was moving what? Which is what? West. To me, west. Like remember, because we're facing this way. North, east, west, south. You were moving this way. I watched you move west. But if you think about it, as you got closer to me, it's as if I was moving this way to you, right? So which way did I appear to move according to him? East. So all you have to do is what? Is switch the direction. Yes. Yeah. Same thing with yesterday. Remember you driving, the trees appear to be moving. That's the exact same thing. Yeah, they're not, but they appear to. Thank you. Yeah, I mean, think about it this way. It's as if you came to a stop and the trees on a conveyor belt started moving backward. That's exactly the same thing. Yep. So what would this be? This one would be what? 80? No, 90. And I'm just going to skip the kilometers per hour. So north. Hold on. You have to write it the same way first. Plus 80. But which direction now? No, not east. No. Remember, we're going to flip. I was moving to your. Oh, you're subtracting. I like to put the plus first and then show the subtraction. You're skipping. That's fine. Absolutely fine. But I just want to show you why the subtraction is going to happen. You're right. You're already skipping a step ahead. So south, which means what? 90. North minus what? 80, which is what? 10 kilometers per hour. In which direction? Does that make sense? Everyone, if oh, okay, because this is not the velocity of car A according to the ground. This is the velocity of the ground according to car A. Do you see what I mean? VAG is pointing which way? So whenever you flip the subscripts, what do you also flip? You also flip this guy. So I just flipped it. V going south. Uh, just to do the math. You see, the physics is this step. The math is just what? Flipping it. Okay, question. Yasmin, do you mind getting up? Okay. Everyone, I'm car A. Yasmin is car B. All right. You're to my left. So let's first walk just the same pace. Go ahead. Okay, speed up. She's walking what? She's walking away from me. Which way? Which way? North. But is she walking away from me very fast or just a little bit? How much is that little bit? It's the difference between what? 90 and? That's why it's what? 10 kilometers north. Do you see what I mean? Question for you. What if both speeds were 80? Yes, me. Question. What if both speeds were 80? Technically, would I see you move according to me? No, which means what? It would be, exactly, it would be 90 north plus 90 south. What's 90 north? Say it. Yeah. Yeah. So I would say 90 north plus 90 south. Yeah. No, no, no. The first time you put it, it has to be with the flip direction. Everyone, you cannot flip the direction and what? And flip the sign at the same time. The first step is you only flip the what? You only flip the what? Direction. This the, it does because you see VAG is opposite of VGA. Uh-huh. Yeah, but that was not relative. There was nothing relative to something else. You only do that in relative motion only. Everyone, our techniques here only apply to what? What's the lesson? No, no. What's the lesson? Relative. This technique, this trick only applies to what? Relative motion only. So what could I say? This car appears to be going at what speed? 10 kilometers per hour. In what direction? In what? Yeah, because he's what? He's moving faster and faster, which means to me he's just going 10 kilometers per hour north, according to me. Yes. Sure. Yeah, because then it would be 90 north plus 90 south, right? Which is what? 90 north minus 90 north, which is no, no. If they were both 90, if you're saying if he kept exactly at the same speed, that would be 90 minus 90, which is what? So we are both moving, but to me, he doesn't appear to what? Everyone, you have to get used to the word appear. Appear is basically all about relative motion. Okay, that's it. All right. Next question. Can someone read the next question for us? It's actually not math. It's just what's the next question? Uh-huh. So to us humans, what is the only thing that basically we take to be non-moving, fully stationary? Which one of those four objects? What objects do you have? Oh, sorry, what options do you have? The sun, the Milky Way, and the universe, and what? What's the fourth one? Okay, what's the third? Sorry, say them again. Uh-huh. It is the what? It is the, directly. What are we in contact with? We don't really care about the sun or the Milky Way or the what? The one we are assuming that I am not moving with respect to is the what? Is the earth. So everyone, which we call what? Ground. Ground and earth are the same thing. Okay? All right. Earth. Okay, next one. Okay. A passenger at the rear of a train. Okay, so everyone, let's say we are on a train, and let's say this is the rear of the train. So this is the back of the train. Okay. Does what? Traveling. No, by the way, who's traveling? The passenger or the train? Who's traveling at 50 meters per second? Train. So the train is traveling at 50 meters per second. Or do you remember the quick trick of going from meters per second to kilometers per hour? What's the magic number? I mean, you could do it with the fractions, but what's the magic number that always jumps you back and forth between kilometers per hour and meters per second? Come on. Who remembers it? I'm just trying to give you a sense of how fast the train is actually going. Who remembers the number? 3.6. Multiply that by 3.6, you will get how fast the train is going in kilometers per hour. Okay? All right. Relative to the what? Perfect. So we know the velocity of the train according to what? Ground. So we know V. What's a good subscript for train? Capital T. What about ground? So V, again, don't write it down. I'm just saying it. VTG equals what? Come on, equals what? VTG equals how much speed? 15 meters per second. But you need the direction. Does this question give you directions? Thank you. Make your own. What direction could you go with? Could you just go with forward? There you go. See? Uh, perfect. But let's actually keep it what? Let's keep it with directions now. Okay. 1D, it's fine to what? To do what do you call it? To do directions. So let's say north. Okay. Second. Oh, like yeah, sure, forward. Or honestly, just give me an arrow that goes to the like to the right, I guess. Yeah. Throws a baseball with a speed of what? 15 meters per second in the direction what? Opposite to the motion. So if he throws it opposite, which way is he throwing the ball? North or south? South. Perfect. Okay. To the motion of the train. What is the velocity of the baseball relative to a ground observer? Okay, everyone, listen up. How many people here? Okay, how many people here actually, when you go to your airport, to the airport, you don't walk, you take the conveyor belt. Okay. What does the conveyor belt do? It's already what? It's already in motion. So my question is, if you just stand on it, are you going to stand still or actually end up moving? Why? Because it's moving with you. If you move on it, you're physically moving what? Slower or faster? Is there a way to move on it at the same place? Yeah, walk what? Walk what? Backward. Like a what? Like a treadmill. What do you do on a treadmill? Do you physically move forward? Do you physically move backward? Because the treadmill is what? You are going against the treadmill, right? So that means what? A conveyor belt that you walk perfectly at what? At the same speed, but going what? Backward. To someone just standing outside, someone just standing outside, you're also what? You're keeping your spot, right? Is that making sense? So here's the thing. The passenger at the rear of a train, so the train is like the what? The conveyor belt. If the passenger is just standing like this, what would he end up be doing? Move with the train at 15 meters per second. We said going north. Then he does what? He throws a ball. At what speed? 15 meters per second. My question is, the 15 meters per second of the ball, is it according to the train or according to the passenger? By the way, do they tell you anything about the passenger walking in the train? Perfect. So that means what? The passenger and the train. By the way, imagine the train is made of glass. Can you see it from outside? Yeah. By the way, always imagine things that you can actually what see on the inside. So I'm the. By the way, am I moving? No, I'm the ground observer. I'm looking at a train made of glass. Go this way. There's someone standing in the train. Is that person and the train moving together? Perfect. So that means what? Both of them are going at what speed? 15 meters per second, same speed, moving north. This guy then throws what? 15 meters per second going this way. But this way where? Inside of the what? Inside of the train. Do you see what I mean? So let's say, for example, I see two people in the train. One of them about to throw a ball, and Muhammad, for example, just sitting in the train. Muhammad is going to see the ball, move at what speed? By the way, do you even know you're on a train? Does he even know that he's on a train? No. See, if he's aware that he's on a train, he's going to actually think how other people watch the ball moving. Always assume that there's no sensation in physics problem because it screws things up. Yeah, okay. When you're actually driving, you know that the trees are not moving. But what if you had no sensation? What if the car and the road were super smooth? Would you think then that the trees are moving? Do you want to? Okay, here's a very scary feeling that I go through like a few times a year. I'm parking. Okay, so this just happened to me last week. So I'm parking, Walmart, just parking where there's a sidewalk. You know how sometimes parking like the park spots have sidewalk. So I'm parking. When you park, what do you do? Do you speed up or slow down? Yeah, I'm slowing down just to come to a stop. Here's the problem. The guy next to me decides to move backward as I'm slowing down. I know I just fully pressed the brakes. I'm done. Problem is, he starts moving backward. What does that seem to me? That I'm still moving forward. The car is in park, and I just slammed the park, and I because I thought I'm still what? No, I wasn't moving forward. He was moving what? But I, for a second, lost sensation that I was what? fully stop, and I just caught it with the periphery of my eye that he's moving this way. Shit, I'm moving this way. No, I'm not. I'm actually what? Parked. But because I thought I was, do you see what I mean? That's why sensation really, really is either very important or very destroying to our physics problem in that. It was like, wow. The problem is, and one time it happened to me as I was parking in front of a hospital, and there were outpatients in front of me. So I thought I'm just gonna ram into them because I thought I was moving what? But it just happened that as I parked, he started moving that way. Oh, that was one of the worst feelings ever. Okay, so everyone, what subscripts are we gonna use? What are we gonna call the train? By the way, you can call it train or P for passenger. Doesn't matter. So we have a train or a passenger. What do you also have? A ground. And what do you also have? A baseball or a B. Okay, so everyone, T for train. Yes, go ahead. So usually there is a ground. Yes, and we just need to find what velocities are according to it. Yes. So everyone, train. B is ball. And what was last? Ground. Okay. Yes. That's fine. And okay, you could assume again if there are no other ways to relate to the ground, then you assume the plane is the what? Because you assume you cannot feel anything on the outside. What if there are three people on the plane? Okay, the plane's gotta be the ground. You're one of the people, and the other two are one of the other. See what I mean? You just have to have one that seems not to be moving. That's all. Okay, this 15 meters per second is the speed of the what? According to the what? Perfect. So everyone, V train to ground equals what? 15 meters per second. Ali said we have to pick a direction. Let's go with north. Sure. Okay. How about the velocity of the baseball according to someone on the train? It's 15, but which way? South. Thank you. So B, according to the train observer, 15 meters per second in the south. The question is asking for what? What is the velocity of the ball relative to the what? So we want V, B, according to G. Okay, I need someone to write the equation for V, B, G. Go ahead, V plus a V. By the way, the equation always has a plus. It's the math that could make it minus after. Who would like to fill in the subscripts? And by the way, everyone, one common mistake in people filling subscripts, they only use one subscript. They say VB equals VG plus VT. You can't. Every V has to have how many subscripts under it? Because it's one relative to another thing. Yasmin. Okay, Hamad, hold on. What did we start with? So, so what has to be here? B. What has to be all the way at the end? And what's missing from the middle? Good. Which one of those do we have? Do we have all of them? I don't know. Look, we do. So what do we just do? We put them as is. So it's what? 15 meters. This is 15, sorry. 15 meters per second. Which way? Plus 15 meters per second. Which way? Okay, come on. What's 15 north plus 15 south? Zero, as we expected. It's the treadmill, right? Someone is trying to walk on the treadmill, but they're walking perfectly as much as the treadmill is what? Pushing them back. So to someone standing on the outside, that person is just what? Where are they moving? In the same in the same spot, exactly. Which means to them they are not moving. Zero speed. So 0 meters per second. But now there's a problem. It's a relative velocity, not a relative speed. I need a direction. It doesn't matter. You can put north or put what? But we kind of standardize everything to start with what? Sure, no problem. Okay, remember, it's a debate. Zero could have what? Zero could have no direction, or it could have what? Any direction, right? Because it's zero, it has no size. So you could say it doesn't point anywhere, or it could point what? Everywhere. And we take the notion of pointing everywhere to say, you know what? Just put one of the directions to it. Okay? Yes. Sure. Okay. Now, can you see that slide or no? All right. I'll zoom in. Okay. Can someone tell me what the question is? Come on. What's the question? What is the what? What is the walker speed with respect to the train? Okay. Is it already given to you? Look at all the speeds. By the way, they're all labeled. Do you know how fast or how quickly that person is walking to someone on the train? Does it tell you? What do you think? It actually does. Yeah. Velocity of walker according to what? Train is how much? 10. Not. Oh, sorry. This actually, this is not meter. Yeah. MPH. I know that M stands for what? M stands for meters. But when you actually say MPH, that's actually what? Miles per hour. Miles per hour. Okay. Um. So that's it. Do we have to solve anything? Nope. Not for this one. Okay. So go ahead and just circle what? Yeah. Ah, there we go. Go ahead and done. By the way, did they ask you for the walker's speed or velocity? Speed. So are we okay just saying 10 miles per hour? What if we said velocity? What would we just need to pin next to that? I need a direction. Then we could say north, east, whatever. Okay, but they said speed, so we're fine. Okay, all right. Next one. Okay, a woman on a bicycle travels at what speed? Come on, 9 meters per second relative to the what? Good, no guesses there. So what's a good subscript for woman? Capital W. Ground is G. So VWG is equal to 9 meters per second. And we can go with Ali's choice before and say it's also north, unless they say something different. No, they don't. As she passes a little boy on a tricycle going in the what? So they're definitely going which direction? Which is, if we pick north, that would be south. If the boy is traveling at a speed in the south direction of 1 meter per second, relative to also the what? To the ground, how fast does he appear? You see, appear to be moving according to who? To the woman. All right. What subscripts do we have? We have W. Go ahead. We have G for ground. And we have what? Who's the third one? Hmm? B for boy. Yep. All right. What's the velocity of the woman according to you on the ground? 9 meters per second. I guess we're going to say north also. Okay. What's the velocity of the boy according to also the ground? 1 meter per second. In which direction though? In the south. The question is, how does the woman see the boy? Or what's the velocity of the boy according to the woman? So, boy according, sorry, not G, my bad. Boy according to one, BW. Okay, what's the equation for BBW? B, boy to woman. What plus what? The G, and then you connect the G, and you go to W. Okay, do we have both, or does one of them need to be flipped? Yeah, The BG is 1, so 1 meter per second in the south direction, plus, now V woman to ground is 9 north. So what's V ground to woman? 9 south. Thank you. Hey, what's 1 south plus 9 south? 10 meters per second in the what? By the way, does that make sense? Everyone, yesterday, when me and who did I do the first one with? It wasn't who? Ibrahim. When me and Ibrahim started walking towards each other, did we seem to be going slower or faster? Faster. It was my speed plus his speed. So I think it was 4 paces plus 4 paces, which is 8 paces. Yep. So it adds up to 1 plus 9. Yes. What if the boy and the woman were not going at each other? They were actually going this way, the same direction. Then definitely what? You would not be adding, you would be what? No. Subtracting. And by the way, what if both of them, what if both of, by the way, question for you. We said that if someone is walking right next to you, what's their speed to you? What if they were going ahead of you, but they still kept their distance? Is it also 0? Yeah, as long as they're not moving, whether they're next to you, 5 meters ahead, 20 kilometers ahead, as long as they're not moving away from you, it seems that you're what? You're holding them at arm's length, right? Which means to you, they're not moving because you're moving with them as well. Awesome. Perfect. Oh, I didn't need to. You see, I only do what first? I flip the direction first. I needed to flip the direction because it's WG here, but I need a GW. So I flip the direction. Uh-huh. Only the direction for the first step. Whatever the math tells you to do in the next step, you just do it. You see what I mean? First step is direction, always. Second step, does this need any direction flipping to do the math? Done. That's it. Yeah, because, sorry, not this one. Because this is south and this is north. I cannot do the math. You see, that's what I mean. The physics is the first step. And by the way, every physics problem is like that. And by the way, and Mr. Augusta can tell you the same thing. Every physics problem is only 10% physics at the beginning. 90% what? But the problem with the first 10% is that it's the what? It's the most important 10%. If you said it wrong, everything else is what? Is wrong. You need to make sure that your first 10% is right because it's the building block of the whole thing. Did that make sense? So directions first, and then if the math tells you, yes, yep, I already changed the direction. Yes. Okay. All right. Next. How about this one? Okay, let's zoom in again. Damn it. Okay. What's the what? Walker's. Okay, don't call it speed. We should call it what? Velocity. Walker speed from the what? What do they mean by observers? Oh, everything is an observer. What do you think they mean by observer here? Stationary ground observer. So everyone on top of observers, right ground, because that's what I'm gonna call it right now. Okay. All right. Okay. Let's put some numbers here. Uh, what's the uh, what's the velocity of the person according to the train? 10 miles per hour going which way? Let's call this what? Let's call it east. What's the velocity of the train? By the way, what does it mean when they just say, by the way, it's very common. What does this mean when they say just velocity of train without mentioning a second object? What do they mean? The second object is definitely the what? The ground. Yes. When they say the velocity of the train, it means relative to the what? To the ground. So everyone, this is 40 meters per miles per hour according to the ground. Okay. So let's put some numbers in. Oh, I got. Okay. Let's do this. So, what subscripts do we need? We're not gonna call them observer. We're gonna call them what they are. Ground. So everyone, G for ground. Sure. W for Walker. And T for train. Okay. This is what? velocity of walker to train. All right? Velocity of walker to train. Sorry, not to, relative to, my bad. Is 10 mph. In what direction? We're going to call it east. Okay. How about the velocity of, what is this one? No, but what is it? Train to who? Or to what? Yes. So everyone, VTG is what? Is 40 mph. But I guess in which direction would this be? The walker seems to be going east. Which way is the train going? Whatever is opposite to east. And the question is wanting what? V, the walker, to the what? To the ground. Okay? What's the equation? V, walker, ground equals what? Walker to ground. So relative to ground. Come on, anyone? W, T, and then T what? Okay, Yasmin. Do I have both VWT exactly and VW, so VTG exactly? Again, Yasmin only. Yes. So am I just gonna copy them for now? Yes. Go ahead. Copy down, whatever. That's why you put your inputs. So we're gonna say equals 10 in the east plus what? 40 in the west. What does math tell me to do now? Exactly. No more physics. Just flip. Now, which one would? No, you don't. Thank you. Finally, someone said it. Do you see that when you actually flip those, you do not change the sign, you only change the what? You only change the direction. But when you do the math, do you need to change the sign? Yes. Now, which one would you rather flip? The 10 or the 40? Why? Because that becomes minus and it's a smaller one, so your final answer comes out naturally positive. So we're going to do what? Negative 10 west plus 40 west. What's negative 10 plus 40? It's like 40 minus 10, which is 30, but which way? Which way? West. 30 miles per hour in the west direction. By the way, everyone, does that make sense according to the diagram? How fast is the guy walking? Just what? 10. How quickly are they being pulled back by the train? Do you think they're going to stand still or actually still end up being appearing to move backward? That's like what? Running on a treadmill that's very what? Slow or fast? That's like trying to run on a treadmill that's very fast. You're not going to be able to keep up. What's going to happen to you? You're going to fall what? You're going to fall backward. Make sense? Yes. Okay, everyone, I'm going to stop here. I know there's one more problem, I guess, left, the one with the big diagram, because I really want to do the what? I want to do the 2D problem with you. Okay? So everyone, here is the 2D problem. It's a very interesting problem. I'm going to act it out in a way to actually make it make sense to you. Go ahead. Okay, so I am the helicopter pilot. What does hover mean? Hover as a verb. Are you moving or just staying still? You are keeping your spot. So you are the what? Moving or stationary? Perfect. To us, the helicopter pilot is the ground, right? Because they're not stationary. They're not moving. Keep going. In front of you. Mhm. So we have a carrier, like a big ship, with the engines what? As far as you're concerned, it's just a big what? Just a big box. Do you see what I mean? What? Okay, when you shut the engines of a Navy carrier off, can it actually move through the water? No, it just what? No, you're right. Here's the thing. It doesn't just stay still. It just what? What do you call it when you just go with the flow? Starts with D. Drift. It's just drift. It's a big box. It's a big styrofoam box. Okay, keep going. So everyone, I'm the helicopter pilot. Eyes on me. I'm the helicopter pilot. Somehow I know that the water current of this ocean or whatever is how fast? Come on, 70 kilometers per hour, heading which way? I'm gonna say that north. Everyone, I'm gonna say that north is this way. How? By the way, how could I tell that it's the water is moving this way? I don't know. Maybe there's like a water raft going away. Do you see what I mean? There's something that's basically what drifting, and it's showing me what way and how fast the water is moving. Keep going. Uh-huh. F-15 where? On the carrier. Jet. Uh-huh. What does it do? So to me, this would be the right side. Like to me, this is my right. The jet is moving this way. Keep going. Okay. How many objects can you count in this problem? Go ahead. Sorry, not how. What? Okay. Who would like to give us? Give me one object. Helicopter, 100%. Someone give me another object. Carrier. Someone give me another object. Jet. Someone give me another object. Yes, water, right? But let's think about this for a second. Which two of these four, by the way, so how many objects did we count? But we said we just really need how many? So one of those could be just what? Just removed, ditched. Or two of these move exactly in the same what? In the same way, speed and direction. Which two do you think? Because the carry is just a big what? A big styrofoam box. It just goes with the flow. So whether you look at the carrier or you look at the what? Are both of them the exactly same motion? Great. Do you need to consider both? Nope. You can ditch what? One of them and keep. Does it really make a difference which one you ditch? Absolutely not. However, which one would you rather ditch? Because you have a jet on the carrier. Would you rather ditch the carrier or the water? Yeah, I mean, I still would like to see the jet on the carrier itself. Awesome. So everyone, first question is, go ahead. So there are four objects: helicopter, carrier, jet, and water. That answers the first part of the question. How many total objects are in the problem? The second part, or out of these four, how many, sorry, out of these four, what are the three with velocities or motions that are relevant or important to the problem? Justify which three, or basically, in other words, justify why did you ditch the one you ditched. So I said, however, since water and carrier exactly move in the same way, we can just use one of them. So we choose, again, choose, which means it's completely up to you. We choose the helicopter, the jet. Those are the first two have to be chosen by everyone. The third one, I went with the what? With the carrier, capital C. Okay, so just write that down and stop. Say again? Absolutely not. Absolutely. So what three subscripts am I going to use? I'm going to use H, J, C. If you chose the water, you would just use H, J, W. Absolutely not. That's why I'm telling you what they are the same way. It's up to you. I just feel it's more relevant to keep the carrier than the water. Okay, everyone. Once you write that down, pencils down, and eyes on me. I'm just gonna. No, you're good. You're good. I just want to use this. Okay. Apologies in advance for the noise. Okay. All right, everyone. Who am I? I'm the what? Come on, eyes on me. I'm the what? I'm the helicopter. Am I moving? No, I'm the ultimate observer of the universe. Okay. What is that? Carrier. What is that? Jet. Okay, everyone. Let's do a what if analysis. What is a what if analysis? Let's change the problem to two extremes and see what the problem tells us. Okay, everyone. What if there is no, listen up. What if there is no water current? What if there is no water current? Would the jet ever move? Sorry, would the carrier ever move? No. But is the jet still moving on top of it? Okay, Muhammad, I want you to move the jet that way. Perfect. Which way did I see the jet move purely? Did it move tilted or just straight this way? Why? Because the carrier is what? It's not moving. Okay, let's completely make it opposite, everyone. Let's say the carrier is what is moving with the water, but the jet is not moving. How would I see the jet move? It's not moving, but how would it appear to move to me? Only if the carrier is moving. So go ahead. I want you to pull the table back to you. Right? This is moving, and this is stuck on it, and it just what moves with it. Right? Do we have either of those cases or a case in between? Think about it. One case was the jet is not moving, but the carrier is moving. One case was what? The jet is moving, but the carrier is not moving. What do we have here? Both of them are moving. Both of them are moving. Okay, Muhammad, I'm going to ask you to do something now. Everyone, listen, everyone, if you can just stand up. Just stand up so you can see. Muhammad is going to move this. How does this move? How does this move on the carrier? Exactly which way? This way. Okay, I want you to move it this way. Hold on. Okay. Slowly. Where did it start? Right there, right? Where did it end? So to me, as a helicopter pilot, how did it end up moving? Perfectly east, perfectly north, or somewhere in between? Why? Because how many motions were involved in the problem? Two. It was moving on the jet, but the jet itself was what? Also what? Moving which way? Does it make sense? So every time it tried to move on the jet, it also got what? Displaced which way? Which way? Okay, question for you. What shape am I sketching with my hand? What kind of a triangle? So that means what? We want to calculate the hypotenuse now. Is it making sense? That's how you imagine the problem. Imagine you are the ultimate observer of the universe, and it's trying to move this way, but you're also what? Pushing it this way. Is it making sense? That's why. Thank you very much, man. All right. Everyone, listen up. Listen up. And Mr. Wilkinson will agree to that. So Yasmin is telling me it makes so much sense when you explain it. But when I'm alone, ladies and gentlemen, fact of life. Fact of life. You know what? Fact of life. You never learn in class. You never learn in the classroom. You never do. Guess who's doing all the work? Me. I'm doing everything from sketching to explaining to even the mental math. I'm faster than you on a calculator. You're barely doing anything. But what are you doing? You're just opening the doors. When do you actually learn? You go home, review, talk to others. How do you think we became such good teachers? We tutored and TA'd and taught until our brains exploded. We've said the same thing in different ways to a lot of people. Do you see what I mean? You only learn when you talk to others. Collaborate. That's my point. It's like going to the gym. Right now, I'm taking you to the gym and I'm lifting for you. Did your muscles grow? You have got to go by yourself on your own and lift and struggle and fail. That's the only way you live. There is no magic pill. If there was a magic pill, I cannot teach. Okay? All right. Ali, what's the second question? B. Okay. Everyone, this 17 kilometers per hour north. This 17 kilometers per hour north. That's the velocity of what? According to what? Remember, we have three things here. What is moving at 17 kilometers per hour? We said we're not going to take the water. We said we're going to what? Go in favor of the what? Of the carrier. So the carrier is moving at what velocity? 17 kilometers per hour. According to who? To the jet or according to the helicopter pilot? According to the ground, the helicopter pilot. Nice. So that's what? That's going to be V, CH or HC. It matters which way you do it. CH, because it's carrier according to what? Okay. Now the tricky one. What is that 23 kilometers per hour east? Who's moving that fast? The jet. But according to who? According to the helicopter or according to the carrier? Why can it not be according to the helicopter? For two reasons. If it was already according to the helicopter, there's no problem to solve, right? I just proved to you. Did it move perfectly east or east-north? But the question says what? East. Who sees it move east? A guy on the what? A guy on the carrier, right? Imagine an officer on the carrier. Does he feel the carrier move? No. Remember, sensation is taken out of physics. He has no idea that there is water or a helicopter. To him, he just sees the what? He sees the what? The jet move. In what direction purely? East. You see what I mean? There we go. All right. So everyone, there we go. By the way, do you see, no, before you write, listen up. Do you see how I'm writing it number first equals to what? That's a better way than saying that is equal to this number, because then you discuss what the number actually means. 17 kilometers per hour north is the velocity of what? Huh. Of what? Carrier seen by the CH. Done. 23 kilometers per hour east, velocity of jet seen by carrier. Obviously, the carrier can't see, but we said everything is not an object now. Everything is what? No objects. Everything is a observer. There is an observer on the carrier, an actual Navy commander or whoever who's watching it purely move to the east. Okay, Hannah, can you read for me, please? Question C. How would you? Yes. So basically, how would you see the jet move, right? Would that be V helicopter to jet or jet to helicopter? Would that question ask for VJH or VHJ? Huh. VJ according to what? According to H. All right. Everyone, is this a 1D or a 2D problem? Why? What makes this 2D? I mean, we've been dealing with 1D for the first 40 minutes of the class. One of them is what? East, and one of them is north. So that makes it what? 2D. Every time we had 2D, what did we end up sketching? All right, angle, triangle. All right. Okay. Okay. In grade 12, I will give you what? Relative motion problems, but without what? Right triangles. You see what I mean? Things. Yeah. I'm not. Yeah. I'm gonna tell you that the jet is moving at east 30 north, and the carrier is drifting at west 65 south. You still can do it with trigonometry, but not with SOHCAHTOA. What do you use if you cannot use SOHCAHTOA? Sine law and cosine law. Oh, we save that to grade 12. Okay? Hey, everyone. Which one would this be? The east or the north? By the way, now we're actually what? Now we're solving part C. Now we're solving part C. Everyone, here, look, on this part of the solution, right here, sketch the following diagram. Okay. Which one is this one? East or north? So is this the V? So what's the subscript for this one? V what? According to part B. Which one is going east? Yeah, go ahead. VJC. Okay, where does the other one go? How does it point? North. Here's my question to you. If I put it here, if I put the vector coming out of here, would that be correct? Why not? I mean, I'm still making a right triangle. Everyone, focus with this, because many of you, even after I mention this, will make that mistake. What would happen if I put my second vector? If I put my second 17 vector right here, why would that not be correct? I'll give you a hint. Finish off the triangle. Finish off the triangle. Where is the hypotenuse of this triangle? Just point with your fingers. Which way would it go? It would go this way, right? Is that how the plane moved? Did the plane move downward, like closer to me or away from me? Because it was moving what? North. So where should I put that vector? At the beginning or at the end? Do you see? No, wait a minute. Mohammed, if I put it at the beginning, it would give me this hypotenuse. That's not the correct hypotenuse. That's not the correct. Where's the correct hypotenuse? So where should I put this pencil? Do you see what I mean? Because where's your hypotenuse now? Can someone point? that way. And did the plane move that way? Yes, it did. Because again, it moved that way, not this way. The biggest mistake, everyone, is people put vectors what? Listen, tail to tail. No, don't put them tail to tail. Put them what? Tip to what? Tip here to tail. It's like one vector is done and the other one vector what? Comes, yeah, exactly, picks up after it. Nice. What do I do now? I have to finish the shape. What do I do? Should I use the dashed line or a solid line? Okay, why dash? Thank you. See, you're asking yourself now, did it move that way? Actually, it did, if you really think about it. It physically, but also it kind of was moving on a staircase, right? So, like, but it was doing it so smoothly, you didn't see the what? The little steps, right? So I don't really care which way you do it. However, you know my habit. I usually sketch what the hypotenuse to be dashed. It doesn't have to be. It's a mathematical thing. I'm teaching physics here. Okay. What do we always do? Usually, the first step with a right angle triangle. Usually. No, no, you okay? I am not gonna say no that you cannot do trigonometry first, but usually, what do you find first? You find magnitude. Yes, you find hypotenuse. So here's my hypotenuse, everyone. By the way, isn't this how the jet moves? Look, right? In a continuous motion, that's actually how it ended up. Why? Because every time it got pushed east, it also got pushed what? Exactly. So like this, so it smoothly went that way in a continuous fashion. All right. Okay. Um, so c squared equals 23 squared plus 17 squared. You add them up, you get 818. What do I do with that number? Always, all the time, 24/7. Square root. No way that length or that magnitude with 23 and 17 could be 818 long. What's the square root of 818? Well, 930, so it's on the high 20s. It is. Now, what's the stick fix situation for this problem? 3 and 3. 3. What would this be to 3? Do I need that extra 0? No, that would make it 4 sig figs. 28.60. Okay? Okay, what's my next step? Every single time we had a right triangle, how did we find the angle? Oh, which angle are you going to give me? The top one or the bottom one? I know. You have to tell me why you choose it. You always tell me which one, the end or the start vertex? Always. Do you tell me at the end or at the beginning? No. No, people. Remember the Jack and Jill? Remember the Jack and Jill handout? Remember the car, the practice worksheet number 1? Where do you always find the angle? At the very end or at the very beginning? At the very beginning. Always at the start. Everyone, again, we've covered a lot. You didn't have time to review a lot. But look at all my notes. I never find it at the end. You always find it at the what? Why? Because you tell me how to turn and then what? You tell me how to turn and then what? And then move. You do not tell me how I'm supposed to end. You tell me how I'm supposed to begin. You always find it at the beginning. So what do we put here? What symbol? What's the most famous symbol for angles in math? Yeah, not x, theta, the oval with the line. So theta. So where's my opposite to theta if theta is here? 17 is the opposite. And do you ever use this in your calculations anymore? No, that's rounded, not too good. So theta. Every time. Alpha, beta, gamma. This is the Q. This is the Q in what? In Greek alphabet. No, what's say? Yep, theta. TA. So there's beta and there's theta. Beta is the B, kind of like looking. Theta is THETA. 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 Okay. Tan of theta. By the way, did I need to show the units? I could show them, but what's going to happen to the units anyway? Is it the same unit on top and bottom? Same things on top of each other. What do? They cancel out. Again, you did not need to do that. What do I do with that number? Is that my angle? That's my tan. What do I do? Tan, shift tan or second tan, tan inverse. Okay, again, what's the sig fig situation for 3? Would this be 36.47 or should it be improved? 0.5. Thank you. 7 rounds the 4 to 5. So can someone tell me what's my final answer? By the way, this is a velocity. Velocity is a what? Vector. You have got to write this as a vector statement. So what do you write? V J H equals what? Obviously 28.6 kilometers per hour. But what's the direction of this angle? Come on. Ah, you have to pick two directions. Which way did you move first? And which way did you move second? And what do you sandwich in between? You always put the angle in between. East, thank you. East 36.5. You got it. Ladies and gentlemen, that's our final answer. Minus the problem with the sig fig.